In lecture 24, we continue the problems related to if-else statement and the switch statement, and as well as the conditional operator. So in this problem, we have to write a runner program that reads two integers and then uses the conditional expression operator, which is this. To print either multiple or not according to whether one of the integer is a multiple of the other. So whether numerator can be divisible by could be divisible by the denominator, or the denominator could be divisible by the numerator. It depends. Just take the input from the user. We have declared two variables, integer m and n, and then we say enter two integers, and we take the input, the first input typed by the user, assigned to m, and the next one is assigned to n. Now what we have done over here is that we have run a cout statement, and then we have written a conditional operator expression. So first we need to figure out what we mean by this. So this, if this a logical expression is true, then the output of this whole expression would be this thing only. And if this logical expression from here to here yields false result, then the output of this whole expression would be this. Just to recap quickly, let's go to notepad, and we see that the conditional operator in this expression, we have a logical expression. This logical expression will either return true or false, or we can just say just 1 or 0. So if this logical expression returns 1, then this whole expression would return whatever is written over here. It could be another logical expression. It is actually possible. It could be anything, but whatever, if this thing is true, then this thing is going to be returned wherever this thing is written. What I mean by this return word is this, that let's say if we have a if we just call some function, let's say sine function, and we have to evaluate sine pi by 6. Okay, so pi by 6 I think is 30 degrees. So that's pi by 6 is 180 over 6 is like 30 degrees. So sine 30 degrees, wherever we are calling this function, wherever the return value would be 0.5. So wherever you call this function, this whole expression would be returned by 0.5, provided that we have done it in a legal fashion. But here, if the logical expression is false, or the logical expression result of this logical expression is false, so this thing, whatever is written over here, is going to be returned. So this thing is return if true, and why what is true, this logical expression, and return this part if this thing is false. So coming back to our original problem, we have written that we just have to write that if this thing is divisible by this thing, or this thing is divisible by this thing. So let's say if the numerator or the first number is divisible by the second number, and the remainder is 0. So we have done the equality check operator. We are not using the assignment operator, which is just a single equal to sign. We are using 2 equals to sign, which is checking for equality. So if n is divisible by n, the result of that remainder operation would be 0. So if this thing is true, or if the second number is divisible by m, and the that is actually equal to 0, the remainder is 0, that means that this n number is divided by this thing. So either one of these. So if this thing is true, or this is an OR operator, or this thing is true. So if any one of these expression is true, we know that the OR expression yields or the outputs 1 or true. So if this thing is true or this thing is true, so the whole expression will be taken as true, and only this thing is going to be returned. If this expression is false, or this expression is false, or maybe both of them are false. So if both of these expressions are false, that means the m is not divisible by n, or taken it another way, n is not divisible by m. That means that if both of these expressions are false, then this thing is going to be returned only. So it's just saying enter two numbers. So if we just evaluate this thing, it says enter two numbers, for example 2 3. Let's type it again. Let's say enter two numbers. Let's say if I type 2 and 3, so 2 is not divisible by 3, and neither is 3 is not divisible by 2, so it's just printing not divisible. If we run it this thing again, and if I write 22 and 11, so 22 divided by 11, the remainder would have been 0 in this expression. So this thing is true, so it just short circuits the whole expression, which means if in any OR operation, if the first operation is true, it doesn't need to evaluate the next one, because the compiler knows that, or the program knows that the next one doesn't it's kind of a don't care condition actually. So if this thing is true, that means the whole expression is taken as true, or the return value would have been true, so it returned just multiple. So let's go to the next problem, which is we have done many times. So write and test a program to solve quadratic equation, which is ax square plus bx equals to c plus c equals to 0, and a, b, c are the given coefficient and x is the unknown value. So coefficients are real number inputs. They should be declared of type float or double, since quadratic equations typically have two solutions. You then use x1 x2 for the solutions to be the output. They should be declared of type double to avoid inaccuracies from the round of error, which we have discussed in the previous lectures. Just to recap what we have done so far in the quadratic. So we discussed this thing in lecture number 5. In here we just take the input as float abc, and in that lecture I did the b square minus 4ac, which is also for discriminant, and I take the square root, which is defined in the CMath library, and then we take that, after taking the square root, the first solution is minus b plus the square root of the discriminant divided by the whole expression over 2a. Make sure you use the parentheses. If you don't use the parentheses, it is definitely possible that only this thing is going to be divided by this thing. So always use the parentheses to ensure that whatever expression you have written is evaluated first based on your preferred order. Then we said the solutions are this, and then we checked whether the solutions were equal to 0 or not. So that was done in lecture number 5. And in this complex quadratic CPP file, I also discussed that in live lecture 5. Was that it is possible that the complex solutions are returned. So because we saw that for some of the inputs the results were not a number, and in some of the inputs the results were INF or infinity. So infinity is obviously infinity, we cannot deal with that, but if the equation returns a complex number, this program was returning not a number, because these variables, these x1 and x2, they are taken as real numbers. So in complex quadratic equation solver, what I did was that I take the inputs a, b, c, enter the coefficients of a quadratic equation. The first input is assigned to a, the second one is assigned to b, and the third one is assigned to c. And then I say that equation is this thing, just to announce to the user that he or she has typed the equation correctly. Then I take the discriminant, and that's it. The discriminant is b square minus 4ac. So if the discriminant is less than 0, and if the discriminant is greater than 0, so or discriminant is equal to 0. So we have 3 scenarios. So if the discriminant is less than 0, that means the square root of that number would have been a complex number. So in this scenario, what I've done here is that I've taken the square root of the discriminant. If this thing is less than 0, obviously this thing in D is a negative number. So only in this scenario, this whole code block is going to run. So I have taken the special case that if we have a complex solution, so I take the square root of D, but not here. I've taken it as a real number, and I multiplied by minus 1 just to make it a positive number, so that the square root function does not throw up an exception. Then I think this expression, is a overloaded function. It can take complex values, but just to avoid the complexities, I've just taken the square root of a real number just by multiplying with minus 1, and then I take the real part as minus b over 2a, and the imaginary part as whatever we have computed over here divided by 2a. So this thing could be written as real plus j imaginary, or a plus jb if you want to write that. So what I've done here is that I've declared a variable x1, which is a complex number, and the precision is single precision floating point number, and I have declared a variable x2, and it's a single precision floating point number, but it has 2 parts, a real part and a imaginary part. So the real part is assigned, this part is assigned to the real part of this number, and the imaginary part is assigned to the imaginary part of this number. And same thing has been done to x2, but the only difference is that I have assigned the negative sign, because x1 and x2 are always conjugates if the discriminant is less than 0 or the solution of the quadratic equation is a complex complex solution. So the solutions are x1 and x2, and then we check for the solution by typing in the numbers and just to figure out that this thing is actually equal to 0 and this expression is also equal to 0 if we put the values of x1 or x2 in place of x or x here. I mean, these are just strings, and here we are putting the values so that it evaluates the expression. Else, if the discriminant is equal to 0 or the discriminant is greater than 0, that means the solutions are real. So when the solutions are real, just take the square root of whatever the discriminant is, which is actually positive or 0 in any case, because this thing did not run. So if this if statement did not run, or the logic or the logical expression yields false, so this thing doesn't run, then this else would run, and the whole code block related to this else is going to run. So I just took the square root of this discriminant, and then x2 is minus b plus the square root of discriminant divided by 2a, and this thing is just minus for x2, and the solutions are x1 x2, and we check for the solution whether this thing is actually equal to 0. Here what the only difference is in this actual code is that the coefficients are declared as a float, and we have done some even more checks here. So if a is equals to 0, which is the equality check, that means that it is not a quadratic equation, because quadratic equation is ax square plus bx plus c. So if a is 0, that means it's a simple linear equation. So we just say this is not a quadratic equation because a is equal to 0, and next line, and then we return 0. That means that if this logical expression is true, then this whole code block is going to run, and this will exit the program, this will end the program. Then in the next, if this thing is not true, then obviously this block is not going to run, and then we say the equation is whatever the user has typed here. I can do that in multiple lines if I want to, because this compiler just simply ignores the spaces. The spaces are for our own easier reading of the program. So this compiler just ignores all these things. I mean, I can just write in even though I could have written in the same line, it's not necessary, because the compiler sees that C out ends at this semicolon. Then I just declare a variables double d x1 x2, and d is the discriminant. If d is less than 0, I'm just going to say this equation has no real solution, and then I exit the program. Return 0 means just exit the program. And if this thing is not true, then I just take x1 equals to minus b plus square root of discriminant divided by 2a, and x2 is minus b minus square root of d divided by 2a. I've not even checked for whether the solutions are okay or not, because we know that there will be some inaccuracies if you put in the values of x1 and x2 in some of the cases, which I have explained in quite a detail when I discuss the finite precision effects of the floating point, double precision floating point, and the extended precision floating point numbers. So what will be your answer in the exam? It depends, really. I mean, if you are just asked to make a quadratic equation solver, which is just putting out the negative numbers or the real numbers only, so you can be done with this program. If you are asked to make a quadratic equation solver which can handle complex numbers as well, so you have to make a complex quadratic equation solver by incorporating the complex header file and making sure that you handle the complex numbers appropriately by declaring the solutions as complex. But first you need to check whether discriminant is less than 0, and then you have to declare the complex number. Some of you might be wondering whether it's actually necessary if you want to check this thing. It is not necessary. Let me clear that I could have, without running this part, without even checking whether discriminant is less than 0 or equal to 0 or greater than 0, I could have taken the input and assign it to the complex float here. But I think it's actually because in that case the solution would have been just the real parts only. I mean, the imaginary parts would have been 0. I mean, it is actually possible to do that with some logic, how to assign those numbers, or this thing is actually much simple, that if this thing discriminant is less than 0, run this code, and assign the real part to real and imaginary part to imaginary, which I find much simple to do. And if discriminant is not less than 0 or it's equal to 0 or greater than 0, then just assign the solutions to the real numbers. I mean, in both of these cases, either this code is running or this code is running, but not both of those codes at the same time. So coming to the next problem, we have to write and run a program that reads a 6-digit integer and prints the sum of its 6 digits. Then the hint is provided that use the quotient operator. I think this question actually came in the previous year midterm. Okay, use the quotient operator, percentage, and use the quotient operator, divide, and the remainder operator percentage to extract the digits from the integer. For example, if n is an integer 8766543, then n divided by 1000, remainder 10 is its 1000 digit 6. Coming to notepad, it says that if n is 876543, so if we divide it by 1000, if we divide it by 1000, so since both of these numbers are integer, so the resultant should have been 876.543, but this thing is an integer and this thing is an integer, and the remainder operator only works with integers, so the output would be 876. So next thing it does is, because division and the remainder operator has the same precedence, so this expression would be evaluated from the left to right. So the result of this n divided by 1000 is 876, and then what we do is we take the remainder after dividing by 10. So if we divide it by 10, and what would the remainder would be? So 10 into 87 is 870, so the remainder would be 6. So 876 remainder 10 would yield this number, this 876. I mean, this thing is the is 1000 digit, was unit, 10, 100, and this thing would be 1000. So that's how we extract the 1000 digit. So let's take the number from the user. So we say that integer n, we just declare two variables, integer n and sum, and we say enter a 6-digit integer. So we take the input from the user, assign it to n, and this scenario, let's say if we divide it by this thing, the first number would be, let's say the user types this number. So what would be the answer for this expression? So n percentage 10. So what would be the output of this expression? So let's go back to notepad, and let's write over here. Let's say the user typed in 876 543. Okay, 876 543. So here n is n percentage 10. So the n percentage, I mean, let's say this thing is n. So if we take 876 543 percentage 10, or the remainder 10, so if we divide this thing 876 543 and we divide it by 10, what would be the remainder? So we know that 87654 would be 876540. So the remainder would be 3. So the output of this first expression would be just 3. Let's make some more space. So we have extracted 3 over here, so we just have to keep it in mind. Then we take the same number and we divide it by 10. So 876 543 divided by 10 would be 87654, because this thing is a integer and this thing is also an integer. So we have this thing, and if we take the remainder for 10, if we just divide it by the 10, so we know that 87654, we just divided by 10, so 8765, and we have 87650, so the remainder would have been 0. So we have extracted the next number. So we have extracted 3 and we have extracted 4. So let's try the third expression here. The third expression is n divided by 100 percentage 10. So 876 543 divided by 100 would return just 8765, because this I mean 876543 divided by 100, this thing is an integer, this thing is an integer, and this would just return this number. And if you just take the remainder after dividing by 10, we know that it will return 5. So we have extracted 3, 4 and 5. We have extracted 3, 4 and 5, and let's go to this part. So n divided by 1000. So n, I mean this expression, n divided by 1000 and percentage 10. So 876543 divided by 1000 would just return 876, and if we take the remainder after 10, we will get just 6 over here. So we have extracted 6 here, and in the last two expressions we just take n divided by 10,000. So if we take n divided by 10,000 and percentage 10, so I mean the remainder 10, so 876543 divided by 10,000 would just return this thing, 87, because both of these numbers are actually integers. So it will just return 1 2 3 4, yeah, it will just return 87 only. 87 percentage 10 would just, I mean the remainder, if you just divide 87 by 10, so 10 into 8 is 80, the remainder would have been 7. And the last thing is n divided by 100,000. So 876543, if you just divide it by 100,000, it will just going to return 8. So we have extracted 8, we have extracted 7, and then we extracted 6, and then we extracted the number 5 and 4, and in the very beginning we extracted a number 3. So we have all the extracted numbers, and the digits could be added with a simple plus sign, and the sum is the unit number, the tenth number, the hundredth number, the thousandth number, the 10,000 number, and the 100,000th place number. The sum of the digit is n, and it will just add up all these numbers, whatever those numbers are in that 6-digit number are. Okay, so coming to the next problem is write and run a program that simulates a simple calculator reads to integer. I think we have done that in the recorded lectures. And if the calculator is a plus, the sum is printed. If it's a minus, the difference is printed. If it's a multiply, product is printed, and divide is the quotient, or the division operation is printed. And if it's a percentage, the remainder is printed. Use a switch statement. We have done that already. We just take the input from the user. We take the we just declare two variables, integer x, y, and we are just assuming the calculator only works with the integers. It should not, right now it simply doesn't work with the floating point numbers or the fractional part, even though you could have done that. So here we have done the, we have taken the input as character op or operator, and we have declared a character, enter two integers and enter an operator. This thing is assigned to this thing, and we are using a switch statement. So switch statement are essentially the parallel scenarios, whether it could be this thing or this thing or this thing or this thing. So whatever, let's say you are traveling on some kind of a road, and that road further subdivides into maybe 4 or 5 roads. So you can switch off one of those roads at a time, whatever the condition is. So if this operator is equal to the plus sign, then we say cout equals to just x plus y. It will just display the sum. If this operator equals to minus sign, we just display the subtraction. If this operator is the multiply sign, we just display their multiplication. If this operator is division, we just declare their division. If this operator is remainder, we just display its remainder, and that's it. You could have done it. You could have taken the inputs to the for the floating point. The floating point numbers can take the integers as well as the decimal fractional numbers as well. So here this operator would not have worked. So you could have displayed some kind of a if statement, or maybe some kind of a check, not in this switch statement, but outside of this switch statement, that if the remainder operator is used. So you could have just typed some condition that if the operator is equal to remainder, then the user has typed in the numbers which are the floating point numbers and not the whole numbers. So you have to then you could have displayed that sorry, the remainder operation cannot be performed or could not be performed. But then in that scenario you have to check whether the fractional part is greater than 0, because if the fractional part is 0, you can just typecast it to an integer and then use those integers to perform this remainder operator. Keep in mind that if the variables are declared as floating point and you are using the remainder operator, I think that is not the valid operation. For the remainder operator to perform correctly, the both of the operands have to be of integer type or the whole number type, integer or the long integer or long integer. I mean, but they have to be whole numbers, or they could be negative numbers, no problem with that. But if the numbers are floating point numbers, then you have to check whether the fractional part is greater than 0. You could have taken the I mean, there are many ways to do that. I mean, you could have developed your own logic if you want to, but you should check whether the fractional part is equal to 0, and then convert those two operands into, or those numbers into, a integer, and then perform the remainder operation. If the fraction part is not 0, just say the remainder operator could not be performed. Rest of these operations could be performed. So you have to develop your own logic. In the lecture, recorded lecture 21, I discussed this thing. I mean, this is a simple calculator, and this code actually used some loops. So that, I mean, loops or iteration means that the code runs again and again. For the, I mean, as long as the condition is true, whatever the condition is, the logical expression remains true. So we just say character reply is equals to y, and this whole code block, which is enclosed in the curly braces of this while loop. I'm going to explain what while loop is in live lecture 25, and if you have time, we can just go to some intro. So in this problem, we just say that as long as this condition is true, the whole thing just keeps on running again and again. So we just declare a variable op, cannot use the name operator as a reserved keyword in C++, and n1 and n2 are declared as two integers. Enter two integers I've synced to the user, and then that first integer is assigned to n1, second one is assigned to n2, and I say that any one of these operators has to be typed. So if this thing is not true, that means for example, the user has typed in some other operator which is not plus, minus, divide, multiply, or remainder, then in this scenario I am enforcing the user to type any one of those numbers, any one of those characters. So if the user has typed, for example, some letter A instead of typing plus, minus, multiply, divide, or remainder, so A is not equal to plus, and A is not equal to minus, and A is not equals to multiply, and A is not equal to divide, and A is not equal to this percentage sign. So this condition is true. So I'm going to say enter any one of the following operators. So and I take the output input from the user, and if the user has typed in one of the correct operator, let's say user has typed in plus, so the plus not equal to plus, this thing would be true, but sorry, no, plus not equal to plus, this thing would be false. Sorry, so I mean, this thing would be false. Plus not equal to plus is actually false, because plus is actually equal to plus in terms of character. So this thing would be false, so it will short circuit the rest of the expression, and this condition would become false, so it will exit the loop and the control will transfer here. I mean, this is just a check to enforce the user whether user has typed in the correct input or not. So, and the rest of the thing is case plus, minus, divide, multiply, and I just say, I mean, I'm also displaying the expression n1 plus n2 and so on and so forth. And I say you want to continue, press y or any other key to exit. If the user presses y, reply equals to y, this condition remains true and the whole cycle repeats again. And if the user has typed some other character, except let's say n or o or whatever, so that o equal to y, this condition would yield false, or this condition would return false. This loop would be broken, and the control will transfer here and here, and subsequently the program will exit. And in the last problem, it says correct the following code so that produces the correct response for all inputs. Actually, this is kind of a fall through here, and what we have done here is that your grade is an F. I mean, what could I have done over here is that this thing I have taken the switch statement, and this switch statement I've just taken it as that if 10 no output, then the falls through to 9, and say your grade is A. And lastly, after grade D, I just say default. It will just go to default. Your grade is an F, because after D, this thing is going to fall through to this line and it will break over here. So I'm just going to say the default statement, and I do not need to write all these lines. I'm going to say after this point onward, it's going to be default to the F grade. So your grade is an F. I'm just going to use the default line here. So that concludes the problems of the if-else switch statement and the conditional operator.